Hello. Today we are going to discuss an industry as a part of municipal and industrial wastewater engineering. It is paper and pulp industry. Paper and pulp industry waste characteristically containing high amount of BOD and color. Here main component for this one is lignin. It is not easily biodegradable. The COD and BOD ratio of the waste very high. It may be noted that pollution potential of the paper mill are negligible compared to that of the paper mills. As such, it is the pulp making process which is responsible for the pollution problem associated with integrated pulp and paper mills. How this will be manufactured? The volume and characteristics of the waste depends on the type and manufacturing process adopted and the extent reuse of water employed in the plant. In the pulp making phase, the chipped cellulose raw materials are digested at different chemicals in one tank under high temperature and pressure. So first you're going to get the wood into cut into small pieces. These chipped pieces of cellulose, that is wood, are digested in a tank by adding some chemicals at high temperature and pressure. The process of thus loosens the cellulose fibers and dissolves the lignin. In the Kraft process or sulfate process of pulp making uses sodium sulfate, sodium hydroxide and sodium sulfide as mentioned for digestive chemicals. The digestion means we are going to break up lignin or cellulose into small pulp. The spent liquor produced by the process of digestion is called as a black liquor. This is not only very rich in lignin content but also contain large amount of unutilized chemicals because the utilization of that cellulose or digestion by the chemicals, some amount may be retained as it is. Therefore, this black liquor that is digested cellulose treated separately for the recovery. The cellulosic fiber, after being separated from the black liquor, is washed and then partially dewatered. So here, from the black liquor, we are going to recover some of the chemicals or unused chemicals. So it may cause pollution when you are going to dispose, or in some cases, treating may be the problem because of chemicals in the biological treatment. The washed cellulosic fiber are then sent to the bleaching in three stages where chlorine, caustic and hypochlorite are used in successive stages. The wastewater from the first stage and last stage are light yellow in color, while that of caustic extraction stage is highly colored. In the paper mill, the pulp is digested into disintegrated and mixed with various filter materials like alum talc and dyes on a long shape, especially pulp is refined in a machine known as Jorda. Now, this pulp is carried by a traveling belt of fine screen to a series of rollers where final product of paper is produced. The drained water, after called as a white water, from the wastewater paper mill section. So here what we are going to do is first is digested, then you are going to go for bleaching in three stages: chlorine, caustic hypochlorite. It is generally yellow in color. Then you're going to pass through this disintegrated and mixed with various type of materials like alum talc, etc. dyes. And you're passing through a conveyor belt to get the final paper. The black liquor of the craft process, concentrated by evaporation and then incineration with the addition of sodium sulfate. The organic like lignin, resin, etc. are burnt off and the smell is dissolved in water. The resulting liquid is known as green liquor. Lime is now added to this liquor, resulting to formation of the white liquor and lime mud containing chiefly digested chemicals and is sent for using digester. Some very toxic waste materials also generated during the process of chemical recovery from the black liquor. Now we'll discuss on characteristics of pulp and paper mill waste. In the most of small paper mills in India, chemical recovery is not practiced due to economical reason. As such, the pollution potential of the waste of smaller mills is higher than that of larger mills. Since in larger mill they are going to have a different treatment procedures. Generally, the pulp and paper mill waste are characterized by very strong color, high BOD, high suspended solids, and high BOD COD ratio. The wastewater of the pulp and paper mill now concentrating on color, BOD, suspended solids, and COD and BOD ratio. Large mills produce large amount of lime mud and without being calcined, it is discharged as a waste. This lime mud in the large mills contribute 86.5% of the total suspended solids in the effluent. So maximum amount will be 86.5% of lime mud. The waste volume produced percentage from the digester sections also higher in the case of small mills, as the entirely quantity of black liquor is wasted in such mill. As you know, what are the waste is coming out from pulp and paper mill, and how this will be going to affect on water bodies, the sewers. Crude pulp and paper mill waste or insufficiently treated waste cause very serious pollution problem. Already discussed, which is having high amount of suspended solids and BOD. When discharged into the streams, the pollution extends over a large stretch due to presence of slowly decomposing component in the waste. Since lignin is a slow in degradation, it will take more time or more length in the river stream. The toxic effect may also be induced upon the flora and fauna of the stream due to sulfite and phenol in the waste. So these are the effect of paper and pulp mill waste on water bodies. How this mill waste can be treated? As I discussed earlier, is having lignin is destroyed. The same may also be recovered from the black liquor by precipitation. These recovered lignin have got various uses in other industries. It is a byproduct recovery from the paper and pulp industry is nothing but lignin. Lignin be used as a dispersing agent in various suspensions. Activated carbon may also be manufactured from the lignin recovered from the black liquor. Chemical treatment mean to remove color. The chemical coagulation for the removal of color is found to be uneconomical. Results are not encouraging. The treatment of green liquor with colored lime sludge results in the formation of a dark brown liquor containing both desired cooking chemicals and color producing component like lignin. This is the typical flowchart of treatment of waste from a pulp mill. First we'll discuss on black liquor, how it is waste will be removed. Other part we are going to discuss on other waste, how it going to be treated. So black liquor containing 80% of BOD. First you go for lime treatment, then clarifiers, cooling towers, then nutrients you are going to add, anaerobic lagooning. So BOD at lagooning is going to reduce to up to 92% in 25 days. Then BOD reduction 87% in again aerated lagoon and detention time of 15 days. So major contribution of this organic from black liquor, where you have to go for anaerobic lagoon and later part you go for aerated lagoon. In other part, you're going to get the waste from the cleaning or washing, etc. First, you have to go for a grit chamber. In grit chamber, you're going to allow particle to settle. Then clarifiers. You're going to add calcium hypochlorite. So color reduced to 70%, BOD reduced to 40 to 50%, and detention time of 4 hours in a stabilization tank. So here we are going to concentrate on second part. We are going to concentrate on the removal of color. In first part, we discussed on BOD. When you're going to get the stabilization, then again you go for aerated lagoon, then you're going to discharge. In again aerated lagoon, after mixing some black liquor and other waste, you're going to detain for 3 days, then the effluent will be discharged. So in physical treatment, circular clarifiers reduce 95% of the solids and 30% of BOD. Biological treatment, stabilization ponds offer the cheapest means for treatment and removes 85% of BOD. In lagooning, we are going to remove nearly 90% of BOD. So in this way, the paper and pulp waste has to be treated before you are going to discharge into the stream. As I discussed earlier, it containing BOD and color is a major component. Color is going to be removed by adding calcium hypochlorite. and you're going to stabilize for 4 hours. Color can be reduced. In second part, black liquor is more amount of BOD. It is going to be removed by lagoon. Another big digesters and aerated lagoon. Later, both water from the black liquor and other waste are go for aerated lagoon, then it will be disposed. Now let us discuss some of the multiple choice questions. Dash removal of the chemical pulps leads to higher fiber bonding strength in the paper. But the strong chemical pulp decrement in the length of cellulose molecule resulting in the weaker fiber is a lignin because it's going to have a good bond. Is easily not biodegradable. So you have to make into weaker so that it can be degraded. The dilution factor is measure of the amount of water used in washing. The Kraft process is also called as sulfide alkali. It is also called as sulfate process. The dash is a device for continuously forming, pressing and drying of paper fibers. It is paper machine is a device continuously forming, pressing and drying of web of paper fibers. The source of dash was arising from the location outside the mills which had to expedite the paper making process is called a recycling fiber or recycled fiber. What is the purpose of Barker? Barker is a process where wood before chipping is going to remove bark from wood before chipping. You're going to get cellulose material for the next process. Pulp from bamboo is utilized in the fine papers is and resulting paper is weaker than paper of straw. The degree of the craft cooked for bleachable grades of pulp have a lignin content 3 to 5% for softwood and 1.8 to 2.4% of hardwood is a soft. Dash is the fresh pulping liquor for the craft processing consisting of activating pulp species NaOH or Na2S, small amount of Na2CO3 is a white liquor. Lastly, the dash is carried by rubbing the surface of paper with rotating wheel. The weight loss is time-based calculated with abrasion test. We discussed about how paper is manufactured, what are the sources and characteristics of wastewater, and how the water is treated before disposing into the effluent, and water bodies, etc. Thank you.